Okay, so this is our final project for CEE11. This is our Huntington Beach TC data project, and we are group 12. First off, why do we want to study TC? Although those TC levels have been decreasing over the last 40 years, we still do get occasional spikes near outlets to the ocean, periodic. I mean, it's not necessarily the big, the small average levels of TC on a year monthly basis we're concerned about. It's the big spikes that can happen in short times that can get people sick. So we want to learn what causes those and how we can control them. So what we're going to discuss is just preparing some CDFs for the data given to us, applying some analytical distributions to doing of analysis for salinity and temperature, and then just comparing the extreme values of the data we're given and coming up with some hypotheses for those. So part one is organizing CDFs. So our group was given a lot of data for 3 years, from 1991 to 1994, and data was taken almost every censored data points, and then also our measuring equipment only moved down to 20 for the TC up to 160 values above, but we really don't have any way of knowing. So the first part was to calculate the CDFs to the north, the zero and outlet in the south stations. So base is we did the natural log of everything, but it was the number of times certain concentration went through. So this is our north CDF. And this is the south and the zero, the Santa Ana outlet CDF. And if you look at all these together, we can now do some comparisons. So sort of what this information tells us. So, for example, we took some sample data points. So let's say we wanted this concentration. This is 3 point, the TC natural log is 3.8. So what value this is the probability of having a concentration less than 3.8. So for the zero station, about 0.5-ish or 0.6, actually 0.6. Here for the south, and it's the highest for the north. So to find what the actual concentration is, it's 1 minus the probability of X being less than 3.8 to find the change be higher than that concentration. So the north station, you actually had the lowest probability of having a higher TC concentration. So that would be the area you'd want to recreate in, because you'd have a better chance of having lower TC concentrations. So part two was finding some parameters and fitting a curve to our CDF. So we were given this this data here. I'm going to hand it over to Dave so we can talk about that.
Thanks, Austin. So here in the slide are just the tools and equations we use to solve for the parameters. Solve for the parameters, we calculated the lambda and zeta by picking 2 points on the CDF, as you can see right here. Into the error function MATLAB to plot this best fit curve next to the empirical of the Allen transform. We found its parameters
So we need.
Yeah.
Yeah. So it's just the video then. Yep. So done. Sweet. Well, I'm already sitting down. It doesn't even matter anymore. Is the table? Yeah, the table's kind of wet. Sure, that's fine. Whatever. Yeah. Events. This isn't even safe.
The table. Table. Sorted.
No, I'm not. I'm not streaming currently. New event. 11. Final.
You can just change the title later, right?
Yeah. I think. Actually. Rerecorded. Okay. Go live now. Okay.